I think we did the voting, but I wanted to find out, kind of forward thinking, how many of you have already considered, let's see, this one. So is your network operations deploying or planning to deploy 40G networks? You already deployed it, first half, second half, you're going to skip it, go to 100, or just sticking to 10G? Okay. Results come in. Right, as I suspected. So many people are continuing to stick with 10G, which means the same problem that we've seen, it stays. We've been solving this problem from 1G to 10G, and now a lot of the networks that may be going to 40G or not, then the question becomes, if I invest in 10G, how quickly can I recover the investment? What's my rate of return on my 10G tool, which is quite more expensive than a 1G comparable, and the traffic that doesn't go from 1G to 10G, right? If you have been deploying 1G tools, your traffic maybe go to 1.2 or 1.6, and you start trunking traffic. So it's going to be a long time before you can recover that. Wouldn't it be nice to be able to maximize the rate of return on a 10G investment? What if I could take the traffic from multiple different, segments, whether 1G or 10G, filter the traffic that is actionable to my, web base or the tool that is supposed to look at web threads or email threads. Not all traffic is actionable by all tools. So this is the level of optimization that we provide. And if you're going to 4G, then the same architecture will allow you to expand the solution that you have to keep up with the speed, as we talked about. So what is unique and different about our network packet broker is just that it's a system. It's much like a Lego system where you can start small, you can solve the 1G, 10G problem with the modular form factors. As you move to a 40G, you change that module to a 40G. If you want to go inline, you basically use inline bypass modules to support IPS tools versus IDS tools. And as we talked about, the job of the MPB is to decouple the tools from the network. We're going to remove the cost and the complexity of packet acquisition or access layer and the delivery of that traffic to the right layers of security monitoring, whether it's performance or forensics. If it's an inline active bypass, if it's a span, if it's a tap, if it's physical, if it's virtual, and we're also working with many SDNs, and really want to decouple that and remove that complexity from you. From the security guy's perspective, you shouldn't be worried about. You just need to have access to that traffic. And the network guys should not be hampered every time that the security guys or the web application team wants to add another layer of tools, whether it's for monitoring and accelerating the performance or to protect the environment. So as I said, this layer, it is designed as a system. We can create full mesh architecture that these boxes can interconnect. They can self-discover and create a self-healing mesh, which means if one of the boxes actually goes down, there's another route for this traffic. This is a layer 2. We take any packet from any of the switching fabrics and deliver it to any of these tools. So let's say if today you have 1G or 10G and tomorrow this link went to be 40G, you don't need to change the tool layers. We can simply extract the traffic of interest from any of these access points, deliver it to the right tool, no matter where those tools are, whether locally present or centrally located in your NOC or your SOC. If you look at the inline deployment, and to summarize this, at a high level when it comes to security and architecting the defense in depth, what we provide is a level of optimization for the tools. Whether it's the speed and medium we talked about, the layer 2, layer 7 traffic filtering and optimization of the packets and the traffic itself, load balancing and supporting asymmetric routes, particularly important when it comes to inline deployments. That allows the tools to be offloaded from non-core functions, and you gain more performance and efficiency of these tools, therefore a much better layer of defense at each of those tools. The security service assurance, which is a huge play, is really creating this convergence platform between network operations and security operations. So we provide high availability for the tools, a fault tolerance for the tools. We can send a packet that actually not only checks that this tool is up, but actually checks that the stack on the IPS is functioning, is not oversubscribed, is not stuck in some memory problem. It's processing all packets. Achieve that service assurance that you need for every layer of the defense. Test that. Make sure that this packet is going in, is representative of your business traffic, so this tool should never block it. Combine the positive and negative health check, combine it with a triggering based on the utilization, and then make a decision. What do you want to do when one of these boxes go down in this whole series? Achieve what we've been, chasing for many years, which is the desire to do security service chaining. Take the traffic, bring it up, decrypt it one time with the transparent SSL proxy, take the copy of the clear text along with the rest of the HTTP or other traffic that is actionable by the layers, and send it to an IPS, to an anti-APT or advanced malware prevention tool. Make copies of it and send it to security analytics. Again, you can do it locally or across that vMesh. This allows you to expand the defense in depth architecture and achieve, whether it's your defense at the edge or defense in breadth, however you want to call it, but the depth on your organization is no longer there, guys. We need to add defense layers on demand and hopefully more proactive manner. Minimize the network re-instrumentation. If I want to add another layer, if I solve my problem for advanced malware in web and I want to focus on email or vice versa, as a security practitioner, I shouldn't be as worried as I am today. How am I going to get access to that traffic? How much change management I need to go through? Do I have access points, whether span or inline, to go in? I want to be able to decrypt once and feed many tools. Why should I pay for the performance of all these NG IPSs out there? So I buy a tool that is supposed to be at 20 gigs or 15 gig or 10 gig rated, but when I turn on SSL and I turn on a firewall or UTM on it, that performance goes down to zero, to almost under 1 gig. That's simply just not good business. If I could decrypt and feed all of them, that's a function that it's not core to those tools. And why do I need to do it 3 times over? What we looked at earlier was basically just looking at this portion of it, which is inline at the edge of your data center or your network, if you will, where you put the prevention tools. Well, what if you want to do security analytics and DLP some other location? We can take the traffic, make copies of that traffic, use the vMesh architecture, and send the traffic of interest to a security analytics or DLP. Again, this is where we can filter and send. If your DLP was supposed to be in the U.S. and your ITAR governed, we can take certain traffic from certain VLANs and ensure they're only seen by that particular DLP. We can ensure the traffic being seen by these guys is cleans, or vice versa. If these guys are blocking a lot of the known bad and dropping it, and if you're looking to do forensics or intelligence acceleration, well, some of the tools further down don't see what is being blocked, so you don't know if you're being targeted or not. What if we could make copies of some of these traffics being dropped and send it over and maybe PCAP it for you into a disk storage in a NAS? Today over FTP, tomorrow iSCSI, FCOE. That allows you to kind of have that information, whether it's for forensics or whether it's for working with your partners to build net new intelligence. Am I being targeted at the edge? This is a view of how expansive this architecture is. And again, we also allow you to have access, as I said, to physical switching fabric or virtual switching fabric. Today we do it without ever needing to deploy an agent in the hypervisor. So to recap, what is the value prop? If I can optimize the security and forensic tools for efficiency, and provide you end-to-end visibility. Remove those blind spots. Then the equation is very simple. You will gain IT security response agility. You will be able to mitigate against advanced targeted attacks or hidden threats to be able to perform forensics on demand. Let's send the actionable traffic to each tool, allow you to keep up with the speeds and the volumes, gain the telco-grade fault tolerance that we have been deploying in the service providers, and allow you to expand this defensive architecture. See all links, see all directions, all packets, maximize ROI from tools, and future-proof investment. Let's build an architecture where you can solve the problem today at the 1G, at one attack surface, and tomorrow when you want to deploy the other tool, we're here to help you expand that. Just to recap, I want to show you one of our customers, major financial institution, actually use this architecture in trying to achieve some of the same challenges we talked about. So what they were asking to do, what they wanted to do is protect their sensitive financial information, obviously, but they wanted to scale and future-proof their security infrastructure. They knew that the existing IPSs, the signature-based and behavioral analysis were just not cutting it. They knew they had a major blind spot. They could not see inside SSL. And they wanted to be able to also look at it from exfiltration. What traffic is going out on Gmail or social media? And they wanted to deploy something that was definitely non-signature based. So they wanted to rapidly evaluate tools to help them protect against advanced targeted attacks. They wanted to continue using some of their 1G tools as their network was moving to 10G. Pretty much some of the problems I was explaining earlier. What we end up helping them with is to provide a very scalable solution that allowed them to achieve security in series with HA functionality. The traffic was coming in, going to a load balance group of SSL or transparent SSL proxies, being sent to the next generation IPS that they wanted to purchase, and in line to another tool for advanced target attack. In this case, I believe this was, I'm not sure if it was a SourceFire and a FireEye, and these were SSL proxies that we had basically brought in, and today you can purchase it from us or from Blue Coat. We were able to brokerage actionable data to multiple tools. Their FireEye was a web MPS tool, and they only wanted to see web traffic, but they also wanted us to decrypt the traffic and send the decrypted traffic to FireEye. We're able to expose threats in an SSL, encrypt the channels, including outbound SSL analysis. So not only just inbound, but also outbound botnet traffic that was going through SSL or callbacks, or malicious, insider threats potentially, or accidental sending traffic out to a Gmail or Yahoo account. The network service assurance that they gained, it was very well received. The network guys, did not want to allow particularly a FireEye tool to go in line, and we were able to show them that they could keep the 5 nines as they needed. They became a big fan, and now the security group has a layer of access that they control with minimal instrumentation, as they want to add the next layer of defense for email, or if you wanted to look at do payload analysis. So this was very well received, and at the end of the day, to summarize what they gained, they were able to get a reduction in risk exposure by being able to see everything that they wanted. They were able to achieve not only security service assurance, but also provide the network service assurance to the operation guys. They were able to keep their 5 nines, so they were happy. They maximized the ROI from their investments. They were able to expand the life of some of their 1G tools and also invest in a 10G and gain the justification they needed to purchase a 10G tool, because we were able to aggregate and provide actual traffic from multiple links. At the end of the day, they gained what they were yearning for, which was IT response agility.